Alright, this is assignment 4. Let W1 and W2 be subspaces for R3 and dimension of W1 is equal to 1, dimension W2 is 2, and W1 is not the subset of W2, right? We have to show that R3 is a direct sum of W1 and W2. So to prove that R3 is a direct sum of these two subspaces, we have to show two things, that R3 is equal to W1 plus W2 and intersection of W1 and W2 is equal to the zero element. These two results we have to show, and then we say that R3 is the direct sum of W1 and W2. Now it's given to us that dimension of W1 is 1 and dimension for W2 is 2, right? So let's start with the proof. Now let's focus on the subspace W2. Since dimension of W2 is 2, right? Which means the number of elements in its bases are 2. So let basis for W2 is equal to, let's say, V1 and V2, right? And since W1 is not the subset of W2, which means the element present in W1 is not the element of W2, right? So therefore there exists V3, suppose, which belongs to W1, but V3 does not belongs to W2, right? Now since V3 is belonging to W1 and we know that V3 is belonging to W1 and V3 is not belonging to W2, which means V3 is non-zero. Yes, so therefore thus V3 is non-zero, as 0 is the element of W2, right? 0 belongs to W2 because W2 is a subspace, and 0 also belongs to W2, right? And the single element V3 is belonging to W1 but not belonging to W2, which means V3 is non-zero. This is the only possibility, that V3 should be non-zero, right? Now if V3 is non-zero, we know that this singleton set is then linearly independent. This is the result, that every singleton set is a linearly independent. Now it is a linearly independent subset of W1, right? And as dimension of W1 is equal to 1, so which means V3 is linearly independent subset of W1 and dimension of W1 is equal to 1, which means V3 is the basis for W1. Fine. So therefore V3 is a basis for W1. Okay. Next, since W1 is generated by V3 because V3 is now the basis for W1, and W2 is generated by V1 and V2, right? So therefore if we take the sum of the subspaces, so the sum of the subspaces is generated by V1, V2, V3. Okay. Now required to show that V1, V2, V3 is linearly independent. Now since V3 is not belonging to W2, right? And W2 is generated by V1 and V2. and V1 and V2 are linearly independent because these are the bases for W2. See, V3 is not belonging to W2, which is generated by V1, V2, and V1, V2 are linearly independent because these are the bases for W2. These are the bases for W2, right? And V3 itself is linearly independent. Yes. So can we say that from here, therefore, V1, V2 and V3 are linearly independent? Yes. So both the results we get that W1 plus W2 is generated by these vectors and these are linearly independent also. So these forms the basis for W1 plus W2. So since V1, V2, V3 are linearly independent and W1 plus W2 is generated by these vectors, so therefore these are the two conditions for the basis. So therefore V1, V2, V3 is a basis for sum of the subspaces, right? Now the dimension for the sum of the subspaces will be now, because these are the bases and dimension is the number of elements present in the bases. So dimension of W1 plus W2 is 1, 2, 3. So it is 3. And this 3 is also the dimension of R3, which means W1 plus W2 and R3 both are having the same number of bases, right? So therefore W1 plus W2 is equal to R3, as W1 plus W2 is a subset of R3 and also their dimensions are equal, that is same bases, right? Same number of elements present in bases. So this is equal. So first thing is done. Second, to show that their intersection is equal to 0 element, right? So let's take one element from W1 intersection W2. Let V is the element from this intersection. So then V is belonging to W1 and V is belonging to W2 both, because this is intersection. So therefore there exist scalars. Now W1 is generated by V1, V2. W2 is generated by V3. So every element of W1, because W1 is generated by V1, V2, so every element of W1 is a linear combination of V1 and V2. Similarly, every element from W2, every element of W2 is a linear combination of generators of W2, which is only V3. So there exist scalars alpha 1, alpha 2, alpha 3 such that V is a linear combination of generators of W1, which is alpha 1 V1 plus alpha 2 V2, and because V is belonging to W2, so I can also write V is a linear combination of alpha 3 V3, because V3 W2 is generated by V3. So this is just a definition. So then, because V is equal to this, V is equal to this, so I'm equating these two. So alpha 1 V1 plus alpha 2 V2 is equal to alpha 3 V3. Taking this to the other side, alpha 1 V1 plus alpha 2 V2 minus alpha 3 V3 is equal to 0. Now as V1, V2 and V3, these are linearly independent, we know this. So therefore, alpha 1, alpha 2, alpha 3, all the scalars are equal to 0. You can also write this as plus negative of alpha 3 V3. So alpha 1, excuse me. So alpha 1 is equal to alpha 2 is equal to alpha 3 is equal to 0 because these are linearly independent. So all the scalars are equal to 0. Now from here, just notice from the star, V is equal to alpha 1 V1 plus alpha 2 V2. So because alpha 1 and alpha 2 are 0, so from here V is 0. If you look at the second one, V is equal to alpha 3 V3 and alpha 3 also 0. So from here also we get that V is 0. So this implies V is equal to 0 from star. V equal to 0 means this implies V belongs to the 0 element. So therefore from where we have taken V? From W1 intersection W2, and this V finally belongs to this 0 element. So which means W1 intersection W2 is a subset of this singleton set containing the 0 element. But the singleton set containing the 0 element is itself the subset of their intersection. So from these two we can say that W1 intersection W2 is equal to 0 element, the set containing the 0 element. Now since R3 is equal to, sorry, I should not write this only plus, sorry. Since R3 is equal to sum of the subspaces and intersections of the subspaces is the singleton set containing the 0 element, so from these two we say that R3 is the direct sum of subspaces W1 and W2. Here ends up the proof. Thank you.